MAP4C 5.3 linear models. So we are going to investigate linear relations in tables, graphs, and equations. A linear model represents quantities that increase or decrease by a constant amount over equal intervals. So the interval needs to be equal, as well as the difference between adjacent values. So what we're doing is y2 minus y1, or the second value minus the first. And if we see that there is an equal distance between these points, then we have linear growth, because that would mean for the same distance in x, we have the same increase in y continuously, which would produce a linear relation. In our second example, we have our hours being equally distant, equally spaced. MAP4C 5.3 linear models. We're going to investigate how linear relations look in tables, graphs, and equations. So, starting off with a table of values, the first differences are constant. So if the x values are equally spaced and the y values are equally spaced, and we can determine that by doing y2 minus y1 for each pair of adjacent points. So in our first example, the difference between adjacent points does not produce constant values. But on the right-hand side, these are increasing by 40 value points each time. Therefore, we can say that this is a linear relationship and this is not. So a way to understand this is that if we have the same increase in x and the same increase in y each time we move, then it's a linear relationship. So graphs of linear relationships are lines. So this is that step, a consistent increase in both x and y that produces a linear relationship. Nonlinear means that we don't have that linear relationship. So equations of linear relationships, they are in the form y is equal to mx plus b, where m represents the slope and b represents the y-intercept. Another way of looking at this is it is a degree 1 polynomial, meaning that the exponent on the variable x is equal to 1. Now we don't see that 1, but we assume that that is the value for the variable. Here we have x squared. This is nonlinear.